So awful, and I was like, thanks, BJ. Okay. Are we only learning until 9? In chapter 9, yes. Okay. We're going to go to chapter 10 next. Okay, so again, I'm going to give you notes on the whiteboard today. I'm just trying to adjust this. It already started recording, just a little FYI. 9.4 is not as long. We are going to basically build on what we've already learned. Again, everything we do in math is building, but especially this section. So just a little heads up on that. I'm just turning this so I can write because I'm left-handed and I struggle. Okay, so the title is 9.4, Circular and Periodic Functions. Okay, so the first thing, and we've already talked about this, we're going to do a little bit about the unit circle. So the unit circle, as a reminder, I don't think I actually said this yesterday, so it is important. First off, the radius is always 1 in the unit circle. That's why it's called a unit, if you didn't know what that meant. Unit literally means 1. So the order pairs for your points on your unit circle from at like 0, 0, if when you just go over 1, at 0 degrees and 180 and 90 degrees and all that, they are just 1, 0, 0, 1, all those fun things. Okay, also as a reminder, your points, so it's usually called P of x, y. For your points, they are alphabetically, so it's cosine, sine. We just talked about this. So your cosines represent your x values. Your sines represent your y values, and that's really important when you come to thinking about positive and negatives in your unit circle. And then something really basic and easy, and this is the first part of your homework, which seems really funny, but for circular functions, okay, they are called circular functions because they're based off the unit circle, okay? And what that means is it literally means cosine of theta equals x and sine of theta equals y. So if you're given a point, you know the answer. So what that means, and literally it's the easiest thing you've ever seen in your entire life. If I give you this example, P of 1/2, square root of 3 over 2. It says the terminal side of an angle in standard position intersects this point. Find cosine and sine. You have no math to do. Which one of those represents cosine and which one of those represents sine? So you literally write cosine of theta equals, and I'm going to write what? 1/2, and then I'm going to write sine of theta equals square root of 3 over 2. And it's legitimately that easy. No. That you will have one like that. That's just understanding that you know what the points are and what they represent. Okay? It is that easy. And there are, yes, some of those on your homework. So it's because just getting you used to the fact that cosine is x and sine is y. That's the whole point of it. Okay? So and also if you notice, this is true. A bonus question. I will give you a sticker if you raise your hand to know the answer to this. What degree is this point at? That point right there. Isaac had his hand up. Huh? No, this is a whole point together. Cosine is 1/2 and sine is square root of 3 at the same time. Which degree is that? No. There,
60 degrees.
it is 60 degrees. That was good. For what? Pi over 3 for radians? So you remember your unit circle. I'll show you right now. You remember this guy and how we just talked about the radians and the degrees yesterday? Okay, hold on. Let me show you something. You see how they have these little ordered pairs right there? Okay. Yeah. Okay. Now, I mean, I could do it in a minute. No, sine at 30, sine itself at 30 is 1/2, which means cosine at 60 is 1/2. The sine was cosine is 1/2, sine is square root of 3 over 2. It would have, if it would have been flipped, it would have been 30 degrees. No, that's not what I said. You do have to have these memorized because I'm not giving them to you for your quiz. The radians and the degrees. No, but you need to know the points for the test on the quiz on Thursday. Okay. So this point, you need to memorize to know them, though, because if you don't know them, you're not going to pass. Look at this. Okay. Okay, good. These points right here, again, are cosine comma sine. So whatever, at 30 degrees, cosine is square root of 3 over 2 at the same time that sine is 1/2. That's what that order pair is. So this point I just gave you, that is 60 degrees. Cosine is 1/2. Sine is square root of 3 over 2. You just switched them. Yeah. Not tangent. 45 is the easiest because their numbers are the same. And these are the easiest to memorize because, zoom out, all these points are the same in the same spot. The only difference is whether they're positive or negative. So the square root of 3 over 2 comma 1/2, see how it's closest to the x-axis? It's also closest to the x-axis over here. The only difference is what happens in the second quadrant. Your x's are negative. The numbers are all the same. Nothing changes. Yeah, they go left to right the same. So middles are the same, tops the same, bottoms the same. And then this way they go vertically. They match up. So the middle one is always square root of 2 over 2, square root of 2 over 2. The closest one to the x-axis are always, all four of them are all the same numbers. Just the negatives are different. That's all it is. That's how you can memorize them. Because when I do these, when I think about all the trig, I do, I see the picture in my head. It's the only way I can do it. Then you have to memorize them. Because I can't memorize to save my life. I'm a visual learner. Nope, it's not. No, because you guys memorize to forget. I memorize to learn. Because by doing homework or practice something, you've internalized and remembered it. It's like learning something. And then all of these points, obviously, because the radius is 1, so on this is 1 comma 0, because if you were to plot a point over here, you would go over 1, up none. If you were to go up here, right, you would go over none, up 1. And then negative 1 comma 0, 0 comma negative 1. Just a little tidbit of information. Yeah. No. You're lucky I'm letting you have one for your Post-test. That sucks. I do this every year. You're the only ones. You're the only ones that I haven't done well. I said I do this every year. You're the only group I've had that's ever done this bad. So I'm still giving you the same information, and you're still getting more learning. Nuh-uh, because they got 45-minute classes. You did it, and also they got more interruptions than you did because they got pep rallies and all that crap that I got interrupted that you do not get. You still got to learn it. They didn't get to learn it. I don't think you understand that you have still got more taught to you than I've ever taught every year. No, not in class. I have not covered 3 chapters in this class. Like, you have gotten more instruction from me, like more help from me than any class has ever gotten. No. No. No, I'm here to teach you the material. I don't have to help you succeed. That's your job. It is your responsibility to learn. I care enough to help you when you don't complain and you're not rude. My job is to teach you, not to be your best friend. But you complaining about it. Yeah, but you guys, all you do is complain or are rude to each other. Like the kids who don't complain or who are constantly irritated by the fact that you are wasting time, they're the ones that get more instruction from me because also they're the only ones that ask for help outside of school. Yes, you do. You complain in every class. You complain in every class. Oh, you complain in every class. Yeah, but in math, if you don't pay attention, you don't get anything done. English, you've been learning the same thing for 16 years. I bet you do not talk as much in her class as you do in mine. I bet you don't. That's 20 minutes. You're interrupting the middle of my class. picture for you to draw. All a periodic function means is that you're looking at a picture to find the length of something. That's why it's called a period function. It means a period length. They always are going to ask you determine the period or how a cycle occurs. So you're always looking at the pattern. So this is where visually understanding what a pattern means. This is the easiest one. So you see how the cycle starts at the top of the point because that's where an intersection is, and it doesn't end until it repeats at the end of the V because then the pattern continues. So then you go, okay, well that's where the cycle is where the pattern stops or before it repeats again. The period length is actual measurement it goes. So since it starts at the origin basically and goes left to right all the way to 360 degrees, the period length is 360 degrees. Now this will switch back and forth all the time from degrees to radians. And sometimes the pictures are much more confusing than this one. So this is the most basic form of this that you can get. And the height of the picture does not matter. We're just looking at the length left to right of the picture. So some of them get a little more intense in its image. And we're going to look at this one right here. Okay, so that picture, this is your first example. We need to figure out the pattern, determine the period of the function. So you need to figure out what the cycle is. Where does this image repeat? So what's the cycle? Yes, so since this one kind of makes like a weird boxy U looking thing, right? It goes from the 0 to the pi. So then what's your period length? Pi, because it's in radians. So it starts at 0 at that top point. Right, hold on. So it starts at 0 here and goes all the way there, and it's above pi. So your period length is pi. And then the pattern repeats every time you see pi. If it asks you to make one, because I'm pretty sure it does at some point, you'll have to make sure you make at least one to show the cycle and another one to show that it repeats. Okay? Here is another one that's a little funkier looking, if I can get it. That guy. That one's a little funkier looking. I'm gonna try to freeze it, but hold on. There we go. So look at that guy. Where does that repeat? What's going on there? That one's got a lot more going on, and it goes up and down. So when the image goes above and below it, you have to make sure it makes a complete cycle going above and below the line and starts back at 0 or the origin or wherever the case may be at the x-axis. So that arrow, you have to think, where does it start? If you can't see it because you know the arrow's right there, you can start at a measurement you can read. Like I would personally start where it crosses the x-axis at pi over 6 and see, okay, it's in between two of them. How do I follow that pattern until it's in between two of them again? What's the number it is? Do you see what I'm saying? So since this has an arrow right there, you can't definitively read it. You should never start at the origin if there's an arrow there. So start at, I know it's hard to read this pi over 6. Since this crosses it, I would start here and go, see how it was going down in between two? I would start here and go, okay, I went down. Now, where did I hit the x-axis again and start to go down again? 1/2. So this is my cycle. Okay, now you have pi over 6 to 1/2 of pi over 2, right? What's that length? It's not 1/2, right? Because we started here, we did not start at 0. So how do we find the distance from 1/6 to 1/2? Basic math. Subtraction. You just do 1/2 minus 1/6. You just use your math or your calculator if you can't do it in your head.
2/6.
It's one card.
2/6 would be
is greater than 1/2.
I thought you said 1/3.
Yes. But you said
2/6 is 1/3.
Okay. Yes. So find if you cannot start at the origin, which is nice, but it's not always easy. So if you cannot start here, start at the x-axis, find where the picture repeats. Do the subtraction and then just write your period, days, and then you're gonna have to write pi over 3. It's not just 1/3, because this has radians in it. You have to put pi. Does that kind of make sense? Do you want another one?
Sure.
No, it's not always that easy. That is a nice thought process, though. It just depends on how they give you back here that information. Okay, find you one that doesn't start. Okay, how about this one? We are going to do that. Wait, 4 seconds. Oh, that goes with the word problem that had one of those pictures, but then it had like seconds on the picture. That's why. Okay, what about this one? This one doesn't have degrees or radians, it just has numbers. This one is kind of what sine and cosine actually look like in a picture. Without degrees or radians, obviously. So look at that picture. See where it repeats. Look at the cycle of the picture and then write the period length. The sticky note's there because of the answers underneath the sticky note. And then I'll show you the one next to it because that one's funky looking too. It is number 3 in your book on your homework page. It's just not your homework. I said it is number 3 on your homework page, it's just not your homework. A lot of your homework problems are like this. Your first 4 are the easy ones where you just say which one sines, cosine are. And then 13 through 18 are just like these pictures. So they're still pretty easy. The last set are the ones where you still have to remember sine and cosine and whether it's 1/2 square root of 3 over 2, practice that part. And we'll do that next. Okay, so what is the period length here? It is 2. Yes, it is. That is actually a picture of cosine, to be more specific to you. Okay. And then I'll show you this one just real quick. This guy right here, I'm going to wake up my computer. This guy's period length, do you see how it has to go above and below? It is 4 pi because it crosses the intersection, has to go above and below, and before it goes back up above, it hits all the way to 4 pi. Okay? And you can see the answer right there. Okay? But some of your homework problems are this easy, where it just gives you the point. You just have to write what sine and cosine are. Okay? Now, the last batch of your homework is just like what we were doing beforehand, where it says, and it's 20 through 25 in your homework, just so you know, where it gives you a problem like cosine. I'm zoomed in. No wonder I'm struggling real quick. Cosine at 690 degrees. It gives you that number, and it wants to know, find the exact value. So you still have to ask yourself first, if you want, which quadrant is that in, Tanner, right? So we can figure out if it's positive or negative. Then find the reference angle, then figure out from there, where's it at? I mean, this is technically a note, but yes, we're doing it right now. So you guys said this is in the 4th quadrant? Okay. What's its reference angle? 60 degrees. And what is cosine at 60 degrees? Okay, well then, you guys are just lying to me. I was just listening to you. Wasn't doing the math, I was just listening. What is cosine at 30 degrees? Square root of 3 over 2. Now you ask yourself, before you're done, cosine in the 4th quadrant, is it positive or negative? It is positive, so this is actually your answer. That is the positive square root of 3 over 2 answer. So if you want to write this down, like to help yourself remember it, first, what quadrant is it in? Things you should always ask yourself. 2, what's the reference angle? 3, if it's not this trig function, if it's not one of the main 3 trig functions, sine, cosine, or tangent, you're going to have to switch it to those, right? So, what is the solution for the main 3 trig functions? So what quadrant it's from, figure that out. What's the reference angle? What would be the solution for the main trig function? And the last step is it positive or negative based on that quadrant? That would be step 4. What is it positive or negative based on that? Obviously, step 4, if it's not cosine, sine, or tangent, then you're going to have to convert it to do the inverse. Those are the questions you ask yourself every time you do these. Nine.
Knowing what sine of 30 degrees.
Well, here's the thing. Sine and cosine at 30, they are opposites at 60. So if you know sine and cosine and tangent at 30, they're all opposites at 60. So you only need to know 30 and know that they're opposites, like you switch sine and cosine. Yes. And then 45 degrees, sine and cosine are the same, and tangent's 1. Yes, because it's something divided by itself. And tangent at 30 and 60 are literal inverses of each other. You flip the fraction. No, because that was just an example. Cosine, so cosine by itself looks like a parabola that keeps going. It has little edges, but sine and cosine look the same. It just depends on where they start. They both look like waves. We just don't have enough time to get into that. I normally make it through all of chapter 9, all of chapter 10, and some of chapter 11. No, I blame COVID. It's the semester schedule. It just threw me off. And I still had to go slower this year than any other year I've ever gone, so it threw it off. Please go back to your seats.